Hello. So continuing with our work with circles, now we're going to move on into cylinders, which again is like a 3D shape. And we're going to find the surface area. So the surface area is all the area around the shape. And a few things that we have is if we look at the top, we can see that, hey, we've kind of got a circle here. And in the same sense, we have that same type of circle on the bottom. So if you look at the first part of our formula, this part right here, pi times radius squared, you've seen that before. This is the area of a circle. And what do we do because we have two circles? We multiply it by 2. So that's how we can kind of get this first part of our formula is we're going to find the area of the top and the bottom and multiply it by 2. Now I want to show you a video kind of what happens when we like take apart this. Let's separate the circular ends. This is the top one. So if we were to like deconstruct this, again, we talked about we have our two top parts, and then if we break apart that middle section and we stretch it out, we actually end up with a rectangle. So as we unroll that, if you think about like unrolling like a pop can or like a Pringles can, you would actually have a rectangle. And so you'll see that, hey, we have the height of our formula is this one side, and then what happens for the top part, it says 2 pi r, because again, how do we find the area of a circle, or excuse me, the area of a rectangle? You do base times height. Well, the base in this case is 2 pi r because it's all the way around the top of the circle. 2 pi r, or 2r times pi, is actually the circumference. All the way around our circle is circumference. So you can see that in order to find this, we take our two areas of our circles, and then we add base times height of the rectangle, but really, instead of base, it is circumference times height. So that's kind of a cool little video of how we derive this formula. If we take a look again, really, Mr. Larson likes to write it as 2rh times pi, because again, you might be able to simplify 2 times r times h. But this part right here is the circumference. And then again, it's multiplied by the height, which is, again, if we unrolled this, maybe we'll just draw it. We saw the video, but we're going to draw it. I've got my top part, I've got my circumference and my height, and then I have the bottom part as well. All right, so let's get into practicing it. So what is the surface area of the cylinder showing? Use 3.14 for pi and round to the nearest tenths. Again, you please use a calculator on this stuff. Anytime you use pi, we'll be using calculators. So I have to determine, am I given the radius or the diameter? So this is the diameter is 2, which means that my radius is half of that, which is going to be 1. This is going to be my h, or my height, even though it's laying down. So 2 times pi times my radius squared plus 2 times pi times my radius times my height. So just simplifying, 1 squared is 1 times 1. So 2 times 1 is just 2. And then we've got 3.14 plus 2 times 1 times 10 is 20. And then we have 3.14 for pi. 2 times 3.14 is 6.28 plus 20 times 3.14 is 62.8. And when I add those together, I get 69.08. And because it says to the nearest tenth, I'm going to round it to 69.1, and my units are millimeters. So the surface area, all the area around that shape, is 69.1 millimeters. This example, determine what you have. This is giving me the radius, which is good. I usually use the radius more. And this is my height. So if I plug it in, 2 times pi times my radius squared plus 2 times pi times my radius times my height. Filling stuff in. Pi is 3.14. 9 squared is 9 times 9, which is 81. Plus 2 times 3.14. 9 times 8 is 72. So 2 times 3.14 times 81 is 508.68 plus 2 times 3.14 times 72, 452.16. And when you add those up, again, don't do your rounding till at the very end. You get 960.84. The 4 would round down, so this is just going to be 960.8, and we are in inches this time. Last example, a contractor builds porch columns that are painted on all surfaces with protective sealant. So again, all the way around. If the contractor has enough sealant to cover 150 square feet, can he seal all surfaces of the column? So we're going to start again. Let's go through and label what we know. We know that this is my height and that my diameter is 2 feet, which means my radius is half that, which is 1. So if we plug in 2 times pi times 1 squared plus 2 times pi times 1 times 14. 1 squared is 1, so it's just going to be 2 times 3.14. 2 times 1 times 14 is 28 times 3.14. So 2 times 3.14, 6.28 plus 28 times 3.14 is 87.92. And when I add all these together, I get 94.2 that would be feet. So if the original question says he's got enough for 150, I would say that he definitely has enough to finish the job because 150 is bigger than 94.2. So yes, he has enough to paint the column with the protective sealant.